The height difference in meters between the water surface and the mean water level of 5 meters at a lake is given by d2h dt squared is equal to negative pi by 14 squared h, where t is the time in days. So we're working in days and meters. The lowest and highest water level is respectively 4.8 meters and 5.2 meters. The water level at t is 0 is 5.1, with the level falling. We're given that h is a cos omega t plus alpha, and we want to find the values of a, omega, and alpha. So, if this is the level, and this is the mean position, which we know is at 5, and then this is at 5.2, and this is 4.8, we can see the amplitude is 0.2. So A is either 0.2 or it's negative 0.2. If we look at H dot, which would be negative A omega cos omega t plus alpha, sorry, that's going to be sine omega t plus alpha. And this alpha we know is going to be an acute angle, so the sine will be positive. The water level will be falling with this expression given the negative out here. So we'll take A to be positive 0.2. Now, the omega is going to be related to this. We know that h double dot is negative, and in this case we're calling this constant omega, so that will be omega squared h. So that follows that omega is pi by 14. So far then, we have that h, the difference in height, is 0.2 cos pi by 14 t plus alpha, and it's just the alpha that we need to find. So at 5.1, h is 0.1, that's the difference. So 0.2 cos, now when t is 0, we just got cos alpha. So cos alpha is going to be a half, which means that alpha is pi by 3. So we can say that h is 0.2 cos pi by 14 t plus pi by 3. We want to now find the number of days between 0 and 28 when the water level in the lake is below 4.9 meters. So that's in a 28-day period. How many days in total is it below 4.9? I might be interested in the period here. So we know that that's 2 pi by, in this case we called the constant omega. So that's 2 pi divided by pi by 14. So that's going to be 2 pi multiplied by 14 over pi. So that is equal to 28, which is exactly the time period we're looking at. So let's graph that. Let's just remove anything we've got here and make sure we're still in radians. That's good. So 0.2 cos pi by 14 x add pi by 3. So that's the graph we want to draw. That's this graph here. So let's graph it. And let's change the scale a bit so that we've got a better view of it. So if we go from 0 to 28, which is the domain we're being given here, and we know it doesn't go up and down that much, so I'm going to go for negative 0.3 and 0.2 here, and then we should have a really good picture. Now, so 4.9 meters means that h is equal to negative 0.1. So let's put on here negative 0.1. Let's regraph that. And we're going to want these two intersections because these are the days where it's below. So, analysis, gsolve, intersection. So that one is at 4.6 and so on. And then go across for the other intersection, which seems to be at exactly 14. So the number of days is going to be, let's just go back to main, it's going to be 14 take away 4.666666. So we're going to say 9.33 days. Correct 2 decimal places.